Hey folks, in this video we're going to explore the world of significant figures. One of the most important things that we need to do when we're making measurements in the laboratory is understand the uncertainty and precision of our measurements, and we need to report the values and the results with appropriate precision. And this is why we need significant figures. So in this video, what we're going to do is we're going to, first of all, define what we mean by significant figures, and then talk about why they're so important. We're also going to learn how to figure out the number of significant figures when we do a laboratory measurement. And then if we do a calculation based on those measurements, how is that precision going to be reflected in our results? We're going to learn how to round numbers appropriately using significant figures, and then we're going to look at a couple of different examples of these significant figures. All right, so what are significant figures? When we look at a laboratory measurement, we are recording values and numbers with a certain degree of precision based on how we're making that measurement. So for example, when we look at this thermometer here, all right, we'll see that the reading is 97.3 degrees Fahrenheit. All right, it has therefore three significant figures. We'll call them sig figs, all right, based on that. And if we're doing a calculation with that number, then depending on the nature of the calculation, we're not going to have more than three significant figures in our final result when we report it. And again, we'll look at some specific examples so we'll understand that. Again, here's another one. Here's a graduated cylinder. All right, and we're reading the graduated cylinder. When we read the graduated cylinder, we're going to see that, just to go through this real quickly, we're going to see there's 20 and there's 30. All right, and so there's 25 right there. Okay, so we're getting something a little bit over 26. And typically what you're going to do in the laboratory, and it's hard to look at and see on this slide, but what we're going to do is we're going to estimate what that might be. So I'm going to say, just based on this estimate, that we've got 26.2 milliliters, since these values are in milliliters. All right, and so again, we're going to see that I've got three significant figures when I make this measurement. All right, so again, the number of significant figures when we're making a laboratory measurement is going to be based on the device and the precision with which we are reading that measurement. So that's, in the laboratory, how we'd figure out the number of significant figures. So we have, in this case, how do we count the number of significant figures? We're going to look at different examples here, which include integers that have no zeros in their number. We're going to look at what happens when we do have zeros in the number, and there are different types of zeros. We're going to be talking about leading zeros. What does that mean? Captive zeros, trailing zeros, and we'll define all these as we look at the specific example. And then what happens when we have exact numbers. All right, so let's first of all look at the situation where we have integers with no zeros whatsoever in the number. All right, so here's an example, 3,456. Now this is not unlike the examples I looked at earlier with the thermometer and the graduated cylinder. This is very simple. If we have no zeros in that integer, then the number of significant figures is just simply equal to the number of digits that we've got in that number. So in this case, we're going to have 4 sig figs. Okay, that's simple enough. All right, so again, just to reiterate, if I've got an integer with no zeros in it, the number of significant figures is just equal to the number of digits in that particular number. All right, so let's move on. That was a situation where we had integers with no zeros. So let's look at some other examples. So what if we have leading zeros? First of all, what do we mean by a leading zero? A leading zero is one where we have a number where the 0 is the first number. Now, typically, this is going to be the situation where you've got only digits after the decimal point. All right, so here we can look at an example of 0.0486, which has leading zeros. Notice that the first numbers in this value are zeros. That's a leading zero. And when we have leading zeros, we will note that those zeros do not count as significant digits. So in this case, we have two leading zeros, the 0 before the decimal point and the 0 after the decimal point. All right, and so those do not count. So when we're counting significant digits, we're only going to count the numbers after the leading zero. So in this case, we have 1, 2, 3 digits after the leading zeros. So this value has 3 sig figs. All right, let's just look at another one just for the heck of it. All right, so I'm going to do another one. And again, when we talk about leading zeros, we're going to be generally talking about numbers where the only values are after the decimal point. All right, so 0.001. All right, now you'll notice here, how many leading zeros do I have? I've got the 0 before the decimal point, and I've got 2 zeros after the decimal point. We don't count those because they're leading zeros. All right, and so now there's only one digit after the decimal point, after the leading zeros. So this means we've got, in this situation, 1 sig fig. All right, does that make sense? I hope so. Let me know if you have any questions about that. All right, so let's move on. Now, what about when we have something called captive zeros? What do we mean by that? Captive zeros are zeros that fall between non-zero digits. All right, and so, for example, then we've got a situation. In this case, the number listed here is 16.07. This 0 here is a captive zero because it falls between non-zero digits. It falls between a 6 and it falls between a 7. And so when we have captive zeros, those are counted as significant figures. So in this case, I've got 4 digits. I've got the 1, the 6, the 0, and the 7. So this one has 4 significant figures. All right, 4 sig figs. All right, those are captive zeros. Now, let's do some other examples here. Let's say I've got 10.005. Again, you'll notice that the zeros, all the zeros in this number, fall between digits. So those are captive zeros. There are 3 captive zeros in this case. So how many sig figs do we have? We count those. So I've got 1, 2, 3, 4, 5 significant figures in this particular number. All right, let's do one more. In this case, we'll do one where we only have numbers after the decimal point. So let's do this. And this one is going to have leading zeros and a captive zero. All right, so we'll notice that here these are leading zeros. All right, and this is a captive zero. All right, so remember, we don't count the leading zeros. We only count captive zeros. So in this case, we're going to have 1, 2, 3, 4 sig figs. And again, the leading zeros don't count, but the captive zeros do. Okay, makes sense? Again, ask questions if you have any. All right, let's move on to trailing zeros. All right, trailing zeros mean that we have zeros at the end of the number. And whether those zeros count or not depends on whether the zeros are before or after the decimal point. Okay, so in the first example given here, all right, the zeros are trailing. That means they're the last values. Again, the trailing zeros are the zeros that are at the end of the number. They're the last values in the number. So those trailing zeros are after the decimal point. If they're after the decimal point, we count them. All right? If they're after the decimal point, they are counted. Okay? So in the first number listed here, we've got 1, 2, 3, 4 sig figs, because both of those zeros are trailing zeros after the decimal point. What about this one? 930. All right, in this case, we have a trailing zero. It's the last zero in the number, but it's before the decimal point. All right, so if we have a trailing zero, there are no numbers after the decimal point. It's not captive. It's the last zero in the number, but it's before the decimal point. We do not count it. All right, we do not count it. So in this case, I have 1, 2 sig figs. All right, that makes sense? Again, if it's a trailing zero after the decimal point, we count it. But if it's a trailing zero before the decimal point, we do not count it. All right, so, and let me just do an example where hopefully there won't be any confusion here, but let's just take a look at another example. And let's say I've got 180.056. All right, just making up a number here. All right, so what kind of zeros do we have in this particular value? All right, we will note that we've got one trailing zero, all right, this zero right here, okay? You might be inclined, based on what we've just talked about, to say that this was a trailing zero, but it's not, because we have numbers after the decimal point, all right? So the only trailing zero here is the zero at the end, okay? And because it's after the decimal point, that trailing zero counts. So the other zeros here, those zeros are captive zeros. And remember, we count those, right? Captive zeros are zeros that fall between non-zero numbers. So how many sig figs do we have in this particular example? I've got 1, 2, 3, 4, 5, 6, 7 significant figures in this number. Okay, does that make sense? So be careful about how you determine the number of zeros. Now, let me give you another number. Let's say this 930 here. Let's go back to the 930 value. And let's say that it had been written 930 with a decimal point. All right, sometimes you'll see that. All right, and that's important. All right, that's really important. If it's 930 without a decimal point, they're 2 sig figs. But if it's 930 with a decimal point, all right, that means we're going to count that. The reason that decimal point is there is to indicate that the precision of our measurement goes down to that last digit. So when we have a decimal point like this, again, there are no digits, there are no numbers after the decimal point. It's just 930 point. If it's written like that, that means I've got 3 sig figs. I'm going to count that zero. Even though it's a trailing zero, because there's a decimal point, it's really not a trailing zero. It's a captive zero. All right, so let's move on to a situation where we have exact numbers. Sometimes, in particular with conversion factors, you'll be told this number is exact. So for example, a conversion factor for inches to centimeters is 2.54 centimeters in an inch, and that is exact. That's how it's defined, all right? If it's an exact number, and again, you'll never have exact numbers in a laboratory measurement, but sometimes conversion factors will be exact. If they're exact numbers, then it has an infinite number of significant figures, all right? So when we're converting that, if I'm using the conversion of 2.54 centimeters per inch in a calculation, then that 2.54 centimeters, even though there are only 3 digits there, that 2.54 centimeters is not going to affect the number of significant figures in our answer because it has an infinite number. Okay, I think we've had enough, so let's take a break. In the next video, we'll discuss computations involving data and significant figures. So stay tuned.